Hello everyone. In this lecture, I'm explain what is Kubernetes architecture. So this is our architecture using one master node and two worker nodes. So now we discuss one by one they all uh, keys: API, server, controller, scheduler, kubelet, and pod, and many more. So now started. Kubernetes architecture overview. A Kubernetes cluster has two main components: the control plane and the data plane, machine used as compute resources. First, the control plane, whose the components used to manage the Kubernetes cluster, and the next worker nodes can be virtual machine, VM, or physical machine. A node hosts pod which run one or more containers. The Kubernetes node can run on regular compute instances or low-cost support instances. Learn more to guide Kubernetes support instances. Kubernetes core components: the control plane, the queue, API server. These are the worker. They all are the They all are a master node. API controller scheduler, etcd, and these are the master node. So first is Cube API server, provides an API that service as the front end of Kubernetes control plan. It is responsible for handling external and internal requests, determine whether a request is valid, and then processing it. The API can be accessed via and the kubectl command line interface or the other tool like Kubedium and via REST call. The next is Kube Scheduler. This component is responsible for scheduling pod on specific node according to automate workflow and user defined conditions, which can include resource request concern like affinity and trend or toleration, priority, persistent, volumes, PV, and more. The next is Cube Controller Manager. The controller manager is control loop that monitor and regulate the state of Kubernetes cluster. It receives information about the current state of the cluster and the object within it and send instructions to move the cluster toward the cluster operate desired state. The next is etcd, a key value database that contains data about your cluster state and configuration. etcd is fault tolerant and distribute. The next and the last is Cloud Controller Manager. This component can implement cloud specific control logic. For example, it can access the cloud provider load balancer services. It enables you to connect a Kubernetes cluster with the API of the cloud provider. Additional, Additionally, it helps decouple the Kubernetes cluster for the components that interact with the cloud platform, so that elements inside the cluster do not need to be aware of the implementation specifics of the each cloud provider. So these are the master services, master node in this key used. And the next is the worker node. They are a worker node. You can see this: kubelets, control runtime, Docker pods, and network proxy, kube proxy. You can also set. The next is node. Nodes are a physical or virtual machine that can run pods as a part of a Kubernetes cluster. A cluster can scale up 5,000 nodes. To scale a cluster capacity, you can add more nodes. The next pods. A pod serves as a single application instance and is considered the smallest unit of in the object model of the Kubernetes. Each pod consists of one or more tightly coupled containers, and the configuration that gone how to container should run. To run stateful applications, you can connect pod to persistent storage using Kubernetes persistent volume. The next is container runtime engine. Each node comes with a container runtime engine which is responsible for running container. Docker is a popular container runtime engine, but the Kubernetes support other runtime that are compliant with the open container initiative including CRIO and RKT. The next is kubelet. Each node contains a kubelet, which is a small application that can communicate with the Kubernetes control plan. The kubelet is responsible for ensuring that containers specified in the pod configuration are the runtime on a specific node and manage their lifecycle. It executes the action commanded by a control plan. The next and the last is kubeproxy. All compute nodes contain the kubeproxy, a network proxy that facilitates Kubernetes networking service. It handles all network communications outside the inside the cluster, forwarding traffic or replying on the packet filtering layer of their operating system. So the next slide, practice on the architecture Kubernetes. These are the functions. Update version, always update latest version of Kubernetes. Educate team, invest in advanced training, developer and operations team. Gone integration, standardized governance, enterprise wide to ensure all vendor and tool are aligned and the properly integrate with the Kubernetes. Scan image. Integrate image scanner into the CI/CD pipeline, including during the build and run cycles. Always suspect open source code from the GitHub repository. The next, control access. Implement role-based access control across all cluster, enforcing the least privilege principle and zero trust model. Restricted user to secure the container, use only non-root user and make your file system read only. The next is minimal based image. The basic Docker Hub image may contain malware or the unnecessary code. When possible, start with clean learn code and the build packages up. In journaling, small images can build faster and take up less disk space. The next, simplify containers. Prefer setting up one process for each container. This makes it easier for the orchestrator to determine and report on the health of the process. Be verbose. Descriptive label can help to other developer relevant parties understand Kubernetes cluster structure and the workflow. The next, avoid over granularity. Not every function within the logical code component should be separate microservices. The next, automate. You can entirely avoid manual Kubernetes deployment by automating your CI/CD pipeline. And the next and the last is manage pod. Prefer prefer using readiness pod and Leibniz prod to manage the life cycle of pods. Otherwise, pods may be terminated during the initialization or receive user requests too early. So this is the Kubernetes architecture. I hope you like the video. So now about MoogleLab. MoogleLabs carry years of knowledge and experience in successfully applying advanced technology to a wide variety of business issues around the globe. We work with the single-minded focus assisting your client to acquire business excellence through the smart uses of the external data and information resources. We are a proficient in artificial intelligence as a service along with this, we offer multiple services such as the machine learning, blockchain, DevOps, and data science, Metaverse, and so on. So subscribe to my channel and ring the notification bell to get notified every time we post here. And you can follow us on Facebook, Twitter, LinkedIn, Instagram also. So thank you.